Let's take a look at a velocity versus time graph. So in the graph above, it represents the velocity of an object over the course of 80 seconds. This is going to be very different than the position versus time graph, so all the rules you had from there, just throw them out of your head. They don't apply to this one. For example, the first thing says, indicate any time in which the student is at rest. Position versus time, you would say that's anywhere where it's horizontal. But here's the thing. Let's say I wanted to claim, well, what about right here at the 25-second mark? Well, the velocity is 3 meters per second, so you are not motionless there. The only point that you're motionless is right here at the 40-second mark. So indicate any time which the student is at rest, 40 seconds. Indicate every time interval for which the speed, magnitude of the velocity, is increasing. So this would be any time velocity is trending away from 0, which happens right here, from 0 to 20 seconds. At the 40-second mark, the velocity is 0. So for the next 5 seconds, that velocity is heading towards -3, which means it is speeding up. Then it continues to maintain the same velocity of -3, and then it speeds up to -5. In general, anytime you're trending away from the x-axis, you're speeding up. Anytime you're trending towards the x-axis, you're slowing down. So we can say the time intervals would be 0 to 20 seconds. It would be 40 to 45 seconds. And finally, it would be 55 to 65 seconds. Determine the total displacement of the cart over the entire 80-second period. So displacement is area under the curve. I have a couple of areas in here that are going to be really annoying to deal with, but we'll get through it. Let's take a look at this triangle right here. This triangle is a 20 by 2 triangle. 20 by 2 is 40. We cut that in half. This is now a total area of 20. We also have here a rectangle, a 1 by 20 rectangle. So the area of the 20 by 1 rectangle is 20. We have another rectangle. I know it looks square on this, but remember the x scale tells us 15 and the y scale tells us 3. So this 15 by 3 rectangle is 45. And the last bit above the x-axis is this 3 by 5 triangle. So a 3 by 5 triangle is going to give me 3 by 5 would be 15. We cut that in half, so 7.5. In the positive region, I have 20, 20, 45, and 7.5. You add all of these wonderful numbers up, it'll be a 12, carry the 1, 92.5 meters in the positive. Now let's take a look at the negative direction. The negative direction, we have a 5 by 3 triangle shown here. The 5 by 3 triangle is going to give us a negative 7.5. Next, I have this rectangle here. This rectangle here is going to be a 20 by 3 rectangle. 20 by 3 is 60, so that's negative 60 meters. I have a 10 by 2 triangle here. My 10 by 2 triangle will give me a total area of 10. And the last thing I have is a 15 by 5 rectangle. So 15 by 5. That's going to be negative 75. So the negative is a 60, a 10, a 75, and a 7.5. So I get 152.5 meters. This is negative because it's in the negative direction. Well, final step. is to say, all right, I got 92.5. Let's subtract 152.5. So 152.5 negative, and the 92.5 is positive. Negative 60 meters is the total displacement. And the last thing is, on the graph below, plot the acceleration versus time. So the acceleration versus time, what you're actually looking at is what is the slope of the line at any point. Let's take a look at the first 20 seconds. The slope of this line is a rise of 2 over a run of 20. Ooh, all right, I'm going to have to change my y-axis scale here really quick. The reason being is I have a rather large quantity of seconds. So 2 over 20 would be 0.1. Let's go ahead and rescale this axis to be 0.1, 0.2, 0.3, 0.4, 0.5. Negative 0.1, negative 0.2, negative 0.3, negative 0.4, and negative 0.5. So again, the first 20 seconds, rise of 2, run of 20, 2 over 20 is 0.1. Not sure how we got that color. Let's try that again. Whatever. I don't care. For the next 15 seconds, the slope is 0. And then the slope is down 6 over 10. So down 6 over 10 is going to be 0.16. Then it's 0 for the next 10 seconds. Followed by down 2 over 10. So that would be negative 0.2. And back to 0. And that's how it's done.